Yes, I actually participated in the group meeting. Yes.
Not yet.
Find the margin of error for a 90% confidence interval when the standard deviation is 50 and n equals 25. Which one is that?
Alright, so. Okay, go back to it. So what would we put in? Margin of error.
Oh, was that where we had it's
I think that's where you enter 90 and
you have the mean, well you have your like your x minus the mean over this over the square root of n. So we have
we know
Isn't that
50
confidence interval.
over the square root of n.
That's your z-score,
I was
doesn't
gonna
it?
say
It's
that's
10.
defining your z-score, right?
I thought it had to do with the z-score. So then we know the mean, or no, we know the standard deviation, we know the population. If we find the z-score, then we can find the rest, can't we? No. Yeah. No. Sorry.
All I remember doing then is you always have like the standard deviation over the square root of n.
This
Yeah.
x minus.
Well,
Well,
I
that's
just remember like this part, the standard deviation over the square root of n. But I'm not the confidence interval. That's what we did that in the
to be written. So n equals 2 times sigma
fine.
over the square root of n, and
Square root
it's
of n
x
is-
minus n plus that.
X plus or minus z times the standard deviation divided by the square root of n. So if we know the z, then we can find x. So then we just need the probability.
Because the square root of n here is 5, and the standard deviation divided by 5 is 10, and it's 2 times that. So
We then know the z-score.
isn't that you're just saying is this one?
Yeah.
Um,
The z-score, you put 90 in the normal probability.
but at this, the equation
Find
you
the,
found
so find the margin of error for a 90% confidence interval, and the standard deviation is 50 and n equals 25. So your confidence interval is this: x minus m, and then x plus m, and m equals 2 times your standard deviation over square root n. So square root n is 5,
further up.
your standard deviation is 50, so 20, but then you have to take your x.
So that's what we just did. Is this, and that's our confidence.
So
Oh,
what's your x then?
but it's not two standard deviations.
Your
away,
point
is it?
estimate. So what's the point estimate?
It's one, not even, it's one standard deviation, isn't it? So it's not 95. This is just as if it was 95, isn't it? 2 times, or isn't it 2 if we two standard deviations away? Or am I wrong there?
Well, it's saying if you scroll up on the thing, there's the graph that's the one that's handwritten. See, one standard deviation on each side of 95%.
Oh, okay. Okay. So what did we get for that?
20.
Is it 20? It says around to 3 decimal places.
Maybe it's not. Click on up. I mean, it says
2 times standard deviation divided by the square root of n.
I didn't even remember the equation.
It's 20.
I was gonna
According
say,
to that equation.
that's what it's giving you for it. See,
Yeah.
but this is what I'm, because so 20 is your m, but it's x minus m and then x plus m.
Okay.
Yeah.
Where x is your point estimate.
So if you want the actual formula for the 95% confident interval for u when standard deviation is known,
Oh,
then you use the normal probability output. You put 90, and you get
oh,
then you
so
do
you-
x minus.
so you get your
and
z
x
score
plus.
for that.
yeah.
So hey, look, that one has it in there.
Has
90.
95.
This one has 90.
Okay.
And so there's your z score. So there's your x, and so plus and minus 20, right?
So 1.645, and then you do 1.645.
So it's 21.645, and it's like 19 or 18.54.
It's not 20 if you have, because you're not multiplying 2 times that. You're multiplying that times the thing. So it's the same.
Oh,
See what I mean? It's not. So you
I
don't
see
have
what
that
you're
2 anymore.
I see what you're saying.
So it's 10 times 1.645. So, oh, 10. So that's 16.45. Yeah, I don't know, I'm using
But you still have x minus that and x plus that. What's x? That's what we're trying to figure out.
Okay. If you know all that, you can find x.
Well, it's x minus that,
It's X plus that, and we're not
Oh, yeah.
getting the-
and you don't know what your
Final
confidence interval is. Your margin of error. My bad. Oh, that's for your confidence interval. So maybe that isn't the right one.
do the control. See,
What
um,
margin of error?
oh, and it's not even a. We don't even.
Plus or
need a
minus the
number.
margin of error. So your margin of error is 2
Mhm.
times that.
But it's not even. We're just the question's on the equation. It's not even on the number.
Find the margin
Oh,
of
I
error for
was looking
90%
for-
confidence interval and the standard deviation is 50. So
Well,
what?
it's still 20.
See, this one says z score times that.
So part of the equation that is added to and subtracted from x is called the margin of error. We denote the margin of error by letter m. M equals z score times the standard deviation by the square root of n.
So it's the z score times 10.
I mean, your z score was 1 point.
So it's 16.45. That's 1.645.
So put 0 at the end. 16.450.
That's if we're doing the margin of error. Yeah, I'm saying 16.450. He's done that
But
before.
you can do negative as well. So do you have 2?
Minus 1.
In this one,
And see, this
according
one's
to
just,
this, it's just asking for the y.
yeah.
If you know the z score.
So which of the following statements is true? Standard deviation squared is an interval estimator of x. X is a point estimator of u. U is a point estimator of x. That was this chart up here at the top. X is a point estimator of right here. It's like your top. It's your number 3. That chart right there.
Oh, yeah. Okay, yeah.
So
I was reading it wrong.
pretty good.
95 confidence interval for G and AT scores. She knows that standard deviation is 113. She puts her random sample of size N64 and computes X is 526.
So this is the one where we want to do it minus.
Yeah. What is the lower?
And so 95, you're going to do 2. This one's 2, because your z-score is going to be 2. If you're 95, it's 2 standard deviations away.
Yeah.
So 2 times 113 over the square root of 64, which is 8. So 113 divided by 8 equals times by 16. Wait, no, times by 2. So 28.25 and x equals 5.6. So 5.6 minus 28.25 is 497.75. So 75 squared. Did I do that right?
That's the lower limit.
Yeah.
So then you add.
And then you do 525 plus 28 or 526.
Yeah.
Plus 28.25. 4.250. I have the right equation for that, right?
526, not 525.
Yeah,
Did you get
Yeah.
554?
Yeah, I put it right in the calculator. I just said it wrong.
Okay. You got 554.
My brain's tired. Yeah. 554.25. That's the one where we're using this one, right?
Yeah.
So what would happen to the
Because
width
that's when the unit.
of the confidence interval if Gina increased the sample size?
If she increases the sample size, the width is going to be smaller. It's going to increase
With the
your confidence interval.
It goes from 20.
Yeah,
so
yeah,
if you do
yeah,
that,
yeah.
It goes from 28 to 24. So yeah, decrease.
Because you're going to have a smaller number that you times in by.
Yeah.
What would happen to the width if changed it to a 99% confidence interval?
that make it wider though, because that's when you get your
Yeah, that would increase it because it's a bigger z-score, so
Right.
you're timesing it by a bigger number.
So Brightbull companies planning to study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. So then we take that equation we had. So if we have
we just put it in backwards, so it equals 50. 400 divided by the square root of
it's
n.
m equals, where is that?
So m is your 50. So 50 equals 95 is going to be 2. So 2 times 400 divided by the square root of what? So
So we can multiply both sides
we'll
by the
divide by.
square root of
So
n.
you can divide by 2. You just get everything off of here. So divide by 2.
M equals 2 times this.
So we got
25 equals 400 over the square root of n. And then times by 400. 25 times 400 equals 10,000. And then you're going to square root 10,000.
Wouldn't you multiply it by n and then divide by 25?
That's what I would have said. You
multiply
go
400 on top.
You divide by 400.
Yeah, but how you do it, you multiply n over there and then divide by 25.
You could do that. Yeah.
That's the way you generally do it.
I think both ways are right. We can do it both ways and see if we get the same answer.
We'll multiply the n over
So if we get
and then
that,
divide by 25. So
well, it's
400.
50. Okay, because we can
So
do
then
it.
the square root of n
400 divided
times
by
25.
So it's going to be 4.
Is 450, and then the square root of n. So then you got to square both sides on it.
Yeah. So you're instead of doing it times n by 400, you're just timesing it by the square root of n. So you're moving n over here. So you have square root n, or 25 times the square root of n equals 400. Divide by 25. Square root of n equals 16. Square root of n equals 4.
Yeah,
Cool, guys.
equals 4. Oh wait, I didn't do.
So the sample size is 4.
Wait, hold on. How do you get 4? That's my question.
Well,
Let's work
so
it
the
out.
way I would have done it is I would have started with n at first.
Yeah.
So I would have times with both sides by n.
Yeah.
And that is the square root of n times 50 equals 2.
You multiply
And
2
then-
times 400, wouldn't you?
Yeah, you
Simplify
could do
further.
that. And then I just do over 50 both sides. And then, so we have the square root of n equals
800 divided by 50. 16.
And then you just square them.
Yeah, that makes sense. The way I
So
was
n
thinking
equals
earlier. Yeah, that makes sense now. That's how you do it.
Oh, wait, no, you
No.
square 16.
Yeah, so,
So
16
n equals
squared.
16 squared.
Oh,
Which is
I was
like,
gonna say
256.
that's too,
I'm like, wait,
too small of a number.
it's 256. He's got to get rid of the square root. Okay.
Alright. The mean salary of actuaries is 100,000. Standard deviation is 36,730. You are interested to know the mean salary for women actuaries is different from the population mean, but not sure if it is higher or lower. You set a hypothesis test of the level of significance. Alpha equals 0.05, and okay, you collect a random sample of. Use the information. What is the lower limit of this 95% confidence? So
Subtract it.
and what percent? Is it 2? So we're multiplying by 2?
yeah, so 2.
Okay, and the square root of 36 is 6. So we got do 36,730 divided by 7
730 divided by 6
times 2.
times by 2 equals 12,243.33. Repeating. It says round to the nearest whole number, so you'd want to round it up, right? To dollars.
Do Jody.
No, you're already good, so you just leave at 3. Then there's a 0.23 because you're not rounding.
Do Jody subtract that from 111,000?
So then we, well, so what's,
We can't find a lower limit.
Yeah.
So it's x minus 2 times the standard deviation divided
so
by
it's
the
just,
population.
it's just 111 minus 12.243. Or 12,243, sorry.
98,757.
Is that right? We just
Whoa.
switched out that answer. It's 2%. That was the right equation to me.
Yeah,
What'd you get?
because it's the lower limit of the confidence interval.
Got 98,757.
That's what I got.
And then we do the same thing plus. So 111 plus 12,243.
So
123,243.
Yep.
Okay. There are 3 requirements that need to be checked when computing a confidence interval for mean. They are X is normally distributed, sigma is
Okay,
known,
this
a
is
simple
how
random
real
sample is drawn. All of the above.
But I don't know. I mean,
Well, I was gonna say when you're computing a confidence interval, you need all of that. You need to know X, and if it's not normally
Yeah.
distributed, then it's not gonna help.
yeah.
You have to know what the standard
first two are
deviation
right,
is.
so you can't.
Alright, and that's all of them.
Okay.
Good job, guys. Here's Cody. Here's Brian again.